Hi friends, welcome to follow up. In this video, we are going to look at today's daily challenge problem 42, trapping rainwater. This is a hard problem in leetcode, and in this video, we are going to explain a method or strategy based on memoization. So first, we are going to look at the problem statement, and then we analyze the constraint and the idea or the method to solve the problem, and then we look at the coding. So actually, the main point of this problem is that how can we compute contribution of each data point to the final result. So we'll make this point clear later. So here we are given n non-negative integers representing an elevation map where the width of each bar is 1. So we want to compute how much water it can trap after raining. So here we have two examples. In the first example, so the output is 6. And in the second example, the output is none. So we are going to look at some details for example 1. So here the constraints are the following. The length of the height, this is the given list, is not empty and also bounded above by 2 times 10 to the power 4. So here the height is a non-negative integer bounded above by 10 to the power 5. So here overall the constraints basically tells us that we need to think of time complexity, right? So for example 1, first we want to notice that so the first cell, the first data point, so here corresponding to 0, actually no matter what it is. And the last data point here is 1, so corresponding to this one. So the first and the last position actually cannot hold any rain, right? So this is the first observation. Well, in order to get the rains contributed by each data point, what we can do is we can get the maximum height to the left of this point and the maximum height to the right, and then we look at the difference. For example, this height at 1. So here, the left maximum is 0, and the right maximum will be this one, is 3, right? So the smaller between the left maximum and the right maximum is 0, which is less than this one. So in this case, there's no rain can be held or can be trapped. So for this position 0 here, the left max is 1, while the right max is 3. So the smaller one is 1. So 1 minus the height of this one is 0, is the contribution of this one. So this is the 1, right? Let's record that. So for example, 0 cell is contribution 0, and the first one, because this one at index 1 contribution 0, and the 0 at index 2, the contribution is 1, right? And for this one, this is a 2, so the left max is 1 and the right max is 3. The smaller one is 1. 1 is less than this one, so the no rain can trapped by this corresponding to this index. So if you look at the 1 corresponding to this 1, so here, so this is at index say 0, 1, 2, 3, 4, at index 4. So you have a 1 at index 4. So the contribution of this one, so here to the left the max is 2, and to the right the max is 3. So the smaller one is 2. So 2 minus 1 is the contribution. This contribution is 1. So now if you look at 0 at index 5, I guess let's actually ignore this. So let's write maybe at index, I guess it's 5, right? I'm not sure, because the index is not that important for contingent contribution. So this has height 0. The left max is 2 and the right max is 3. So the smaller one is 2. So 2 minus 0 is the contribution, is 2, right? So we have 2 here. And then similarly, you can look at this one. The left max is 2 and the right max is 3. So the contribution will be, the smaller one is 2 minus this 1, that can give you 1. So 1 at index 6. So this gives you a 1, right? So this one is highest, there's no range trapped. So for this one, so the left max is 3, the right max is 2. So smaller one is 2. So 2 minus 2 is 0, no contribution. So for this one, so this is a 1 at this index, negative 2, right? So negative, this is a negative 1, negative 2, negative 3. So 1 at index the negative 3. So the contribution, if you look at the left max, that is 3. The right max is 2. So smaller one is 2. So 2 minus 1 is 1. So its contribution is 1. So overall, so 1, that's 1, 1, 2, 1, 1. So the contribution, or the total contribution, is 6. So that's the result. So here, let me restate the observation. So for a position in between, right, I, then we can, the contribution of the range trapped by this index is the minimum of the highest value before I, right? For example, for this 0, the highest value before is 2, right? And then the minimum and the highest value after I. So for example, this one, the highest is 3. So we have the minimum of this 2 and 3 is 2. Then minus the value itself, that is 0. So you get 2. That's the contribution. Then you just need to sum up the contributions. And notice that the contribution cannot be negative. In other words, we need to take maximum of this quantity at 0, right? So now if you know, you digest or grasp the main idea, then you can write different formats of codes. So basically, for this problem, we need a way to know for each index what's the left maximum and what's the right maximum, right? Then this fall in the compass of memoization, right? So let's try to write the code, and then we can explain in between, right? So here I changed the height to be capital H for convenience of writing. So first I get a length of H. So we can treat some edge cases. For example, if n is less than 2, so we just return 0. So no ring can be trapped. And now we want to find these two pieces of information, right? So highest value before I and highest value after I. And then this is very simple. So let's use a left. This 0, so the length is n. And the right, so I'm going to use 0 times n. So basically I want to left I is max height up to and including index I, right? So if you mix this interpretation, the left can be easily set, right? Because left is 0 at index 0 will be nothing but h0, right? And then for I in range, so 1 to n minus 1, right? And then the left I will be the max of the max up to left I minus 1. This is the information up to index I minus 1. And then we compare with h at this index, right? So this you get left. So similarly, you can do right I. So this is max height from I to the end of the height list, right? So here we know that right at n minus 1 will be h n minus 1, right? And then we are going to iterate backwards. So for I in range, so n minus 2, then we need to stop at 0. So we write -1 here, and the increment will be -1. In other words, we decrement by 1. So then the right I will be the max. So the information up to from I plus 1, and then we compare the height at hi. So this way, we get for each index, we can retrieve the maximum before that index or after that index. We just need to be care of the indexing, and then we can get the contribution. So for this, we can initialize a result variable, right? And this is the final state is what we want to return. So then we just need to collect all the contributions. Then basically for I in range, so I'm going to start from 1, then ending at n-2, because the last two positions does not contribute anything. So, and also you will see why we use here 1 and here ending at n-2. So because here, for this one, we want the contribution should be something like this. So the max before this index, that is the left max, I minus 1. Because I starts from 1, so I minus 1 is always in range. And also we need to consider right. So, but we know we need to be right to the current index is right I plus 1. But the largest value for I is n-2. So then I plus 1 is always in bound. So we want to compute the mean of these two, then minus the height and the current index. That's the supposed contribution. But we know we need to take a maximum between this number and 0, right? Because the contribution is not negative. And then the answer increment by contribution. So after this, we can return the result. So this forms a full solution format to this problem. So let's do some test. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the cases. So this actually almost completes the video. But before we end this video, we want to make some comments. So here the comment is the time complexity for this, what we write is O of n. N is the length of the head list. This is very straightforward. And then the space complexity is also O of n. So because here we created a left and a right arrays. But very straightforward exercise is to write the solution with O1 space. This is actually rather straightforward because you just need to use some running variables, or you can use 2 pointers, right? So with that said, I guess that's about it for this problem. Thank you for watching.